Today, let's talk about number 339, nested list with sum. And you are giving a data structure called nested list of integers. It has a shape like example one. And this kind of nested integer has two methods. One is get list, and another is get integer. That this method can only be called when the is integer return true, and it let us to find out the sum. For example, it defines something like a depth, and for example, this is 2, the depth is 1, so we'll sum 2 multiplied by 1, and for every the inner number that is 1 and the depth is 2, so it will 1 multiplied by 2 and 1 multiplied by 2, and this 1 multiplied by 2 is multiplied by 2, the sum will be 10. So we'll say this kind of data structure is pretty much like a tree. We can iterate the trees and find its depths, and for every depth, it multiplied by the value and add to the sum. So we do this way pretty much like we do the way with a tree. So there are two different approaches. One is using DFS for tree. We can write these two methods pretty quickly. So let's I'm going to firstly use the DFS for this question. Firstly, we need to consider whether this tree is empty. If nested list equals null, or nested list of size equals 0, so we just return 0. Otherwise, we're going to return DFS nested list. We have the depth as one of parameter. Let's have the depth as 1, as we started for the root is 1. So let's write the DFS here. For this DFS, it has a return result. Sometimes for DFS, I prefer use the reference type. And then return. So let's write the DFS. So it will be list. Let's do the integer. Int depth and result. So the same thing. If nested list equals null, or nested list dot size equals 0. We just return. So let's iterate the nested integers in this list for nested integer. in nested list. Okay, we know this nested integer. It may be integer. It may also be a nested list. So we'll use is integer method trying to see whether it is integer. If ni is integer, not get list is integer. Let's say sum, not sum, result there plus equals ai dot get integer. And it should multiply by the x s result 0 plus equals BFS in a get list. And now the depth should add one result. So this will be our DFS solution. Get list is integer, sorry. Result 0, result 0 plus sorry. Because this is return void, we just do this. Okay. So this is a DFS solution. As this is a tree, we can also have a BFS solution to do this. So it will also be kind of straightforward. I think we just remove this kind of code. And we still have the spatial corner case here. And what we need to do is that we have a result equals there. And we are going to have a queue. We'll put the nested integer type. New array. So let's iterate this list. We are going to use depth here. Let's put the initial value to be 1. And we need to go through the user BFS by layer. So we're going to use the size variable with Q of size. Then we write for it I equals 0, I smaller than size, I plus plus. Nested integer I equals Q dot 4. So the same thing, we are trying to see if this I is integer or not. If this is integer, we just add a result. That is our result g plus equal to ni dot get integer multiplied by else we iterate for nested integer and ni with list that is a queue offer. We make sure for every layer our depth should increase. Then after that we return result. Let's see. Ni is already we should write while q is not null. Sorry, it's not empty. Q is not empty. Result plus equal to ni multiply this depth plus. Let's take a look why this is 0. Return result. Our result size equals q. That means that we haven't put the original, let's say, integer into the queue for nested integer in line. Nested list integer queue. So this is a BFS. It is just like tree. You can do either BFS or DFS. Both will be kind of straightforward. And we are going to iterate every node for the tree. So if we'll see for the list how many leaves it is. If there are n leaves, the time complexity will be O(n), and the space complexity as we use Q will also be O(n).